Hi everybody, it's Mr. Bennett here. Now today we're going to be looking at the term logs, okay, or logarithm. Alright, so these things are really useful and I just want to do an introduction to that. There are a couple of examples where we use logs in the real world, and that would be the pH scale. Alright, that's the first reason why we use that. The second one that we'd use that for is the Richter scale. So the Richter scale is when you have earthquakes, right? So we know an earthquake, which is say 7 compared to 8, is going to be 10 times more destructive than the previous one, all right? So that's what happens there. And then the third one we're going to be looking at is the decibel scale. All right, so the decibel scale is in fact for sound. And again, a sound which is 1 decibel higher is going to be technically 10 times louder. All right, so rather than it going, so like a normal logarithm graph would go something like this. All right, so it might go something like that. All right, so it's certainly not a linear relationship, and basically things get 10 times louder, or 10 times bigger each time. Now, in maths, you might go, why do we need to use logarithms? Well, the first thing is, if I get given a graph like this, all right, and it might go like that, all right, I have to try and model that graph. All right, this might be a graph of A versus B. Now, if I did that, what we want to do in science or maths is we want to get a straight line graph. So to get that straight line graph, I might go log of A versus B. And if I got that as a relationship, then I'd be, oh, that's awesome. That's my relationship I'm looking for. I might go log of A versus log of B. And that might be the relationship that I'm looking for. Or the third one I might go A versus log of B. Now, in each of these cases, what you're going to get is you're going to get a straight line relationship. So if I got this first one over here, if we did number one, the relationship is going to be something like log of A equals the slope of the line times by B plus where it cuts here might be C. All right. If I looked at number 2, then I could go log of A equals M log B, and if I have my graph and it cuts again at C plus C. And so if I've got that linear relationship, it means that I can then try and solve that equation, so we can actually use that. And that will be, you know, a typical type of maths formula or a science formula that you'd use. Or the third case over here would be something like, cutting at C would be A equals M log B plus C. So each of those would allow me to rearrange the equation to find a relationship between A and B, and we'll do some of that later on. Probably for me, the main thing that I actually want to use logs for is to solve things. All right, so this is the question that's probably the one that gets me the most. If I had 2 to the power of x equals, say, 8, then that's easy, because I know that's going to be x 2 to the power of 3 is equal to 8. Tick. All right, I'm going to do that by inspection. All right, what happens though when I don't get a number that's actually easy to work out? So if I said to you 2 to the power of 7, 2 to the power of x is equal to 7, what's the value of x? Now, one technique you could use is trial and error. That works. Okay, there's no doubt about it, that will work. The easiest way though is to use our log laws. Okay, the log law that we're going to use for this one here is in fact this law here. Okay, I'm going to use this one. So that's log of A to the power of x is equal to x log A. Alright, so that's what we're going to use there. Alright, so when we're going to find the solution for this particular one here, alright, what we're going to do is we're simply going to take the log of both sides. So I'm going to go log of 2 to the power of x equals log of 7 And now I'm going to use this law. I'm going to write this as x log 2 equals log 7. And therefore x is equal to log of 7 divided by log of 2. Now I can go to my calculator and I can work this out. So you've got a log button. Now log is base power 10. So I go log of 7, divide that by log of 2. Maybe if I go back, don't need to put 2 brackets in there. And that gives me 2.81 if I want to go to 2 decimal places. All right, now obviously to get that accurately, you would need to have all those decimal places to get the exact answer. All right, but you know, we're just going to estimate in terms of that. So the expression I've got here is the exact answer, tick. All right, but if I write 2.81, that's going to be pretty close to what we've got. So now if I go 2 to the power of 2.81, it's going to get me pretty close to 7, all right? So, you know, I could make it better by saying 2 to the power of 2.805. If I did that, I'm getting pretty close to it again. All right, get the idea? So the most accurate way of writing it is in terms of logs, but I can actually estimate by doing that, and that's close enough for most things. So the real power of logs is we can use it for representing data in terms of data that's really big, and that grows in a factor of 10, or even another factor. It might not go up in 10s, but it might go up in 2s or 8s or 16s. It doesn't have to go up like that. And then the other thing we're using it for is to solve for powers, unknown powers. All right, now that's an easy one. Sometimes these can be quite complicated, so it gives us a technique to actually solve these equations. So that's probably the real reason why we use logs in maths. All right, I hope this helps.